Hey folks, it's Mr. Woodward showing you how to draw magnetic fields around simple kinds of magnets. So I've got 4 typical magnets that you would see around. One is the Alnico bar magnet. Second is a ceramic bar magnet that's usually cut from kind of like a loaf of magnets, sliced. Ceramic ring magnet. And then this is actually not a cow magnet, it's just a spherical magnet, but it does behave similarly. I couldn't find my cow magnet, unfortunately. So here we go. It says use a compass and iron filings, draw the magnetic field around these common types of magnets. So let's give this a try. We're going to start with the Alnico. So this Alnico magnet, I'm going to bring it here. So you could do this a couple ways. First of all, this is a plastic box filled with iron filings. And if I spread out these iron filings in a thin layer and then put the magnet underneath, I can see a little bit of the pattern that's formed in those iron filings by the magnet. A little bit tricky to see from the camera. If it's hard to see here, the other thing I can use is a compass. So a compass always points in the direction of a magnetic field. So notice that the compass needle here is pointing towards the south and over here away from the north. And this little kind of loop that this is making is a magnetic field line. It goes like this. I'm going to actually move this over here. This little loop, sort of follow the compass needle. If I take this compass this way and now move towards the silver end, this will move out this way in straight lines and over this way in curved lines. So I get a magnetic field line here and another one here. If I move it here, now the silver is pointing straight to the right from the south and would go kind of out this way. Now it points, wow, kind of down this way. It makes a big loop around. And then I've got another one here looping. And then from the north end, my compass points out this way. My compass points out this way. So that's generally what the iron filings were doing in the little viewing window here, is they were moving in these sort of half circles above and below the magnets. You can also do it like this. You can kind of see it there, how they're moving in this arc across the top, arc across the bottom. Maybe if I shake them around a little bit more, it's easier to see. All right, so we're going to draw that one here for the Alnico. So the filings kind of create this kind of a thing. And so in the diagram, we always draw magnetic field lines from north to south. That's the official direction of magnetic field lines. Away from north towards south. So that's the direction that a compass would point at all of those locations around the magnet. Let's try the ceramic bar magnet. That's this one. So now if I take my iron filings and I shake these around a little bit and I put this magnet on, I get definitely an attraction to the magnet. And in terms of that shape, can you see on the edges over here? It's moving outwards, sloping back around this way. If I use a compass, now I get the compass needle is going towards the center of it, sloping around the outside. And then, interesting, this wraps around now the bottom part. These go straight out over here. These go straight out on that side. The orientation is quite different if I hold it this way. Now you can see the compass doesn't really respond as much. The compass seems to just stay in the same spot because the magnetic field lines are much more visible in this orientation. So that's what I'm going to draw. Ceramic bar magnet, when it's drawn kind of like this, has these lines that go, if this is the north face and the south face, then you have sort of all these magnetic iron filings going around like this. And so the official diagram for this one, this is my north face, and then this backside would be my sort of south face. And the magnetic field lines come out of the north into the south, out of the north into the south end on the backside. So those field lines are wrapping around from the front, around behind. So this whole thing is like the north face of that magnet. Let's try the ceramic ring magnets. Here's the ring magnets. Here's our iron filings again. If we hold the ring magnet underneath those filings, they do move. You can see very faintly on the edges, they're moving outwards. And then I can also hold the magnet this way, and I get some different patterns. On the edges here. There we go. So it's again helpful to use the compass to really highlight what's going on here. This is going to do the same thing as the ceramic bar magnet. There's a loop around the top. Here's a loop around the bottom. As we move outward, these go straight. Those curl down. These move outward. And then on this side, these move outward. This moves outwards. And then in the corners is where the looping is happening. It's coming back around this way. So I'm going to draw that in 3D. Let's see if I can do this. This, so this kind of produces iron filings that kind of go out like this. And the official diagram would have the magnet on its side. This is now the north face. This is the south face on the back side. And those magnetic field lines are wrapping, again, similar to the ceramic bar magnet, out of the north into the south, out of the north into the south. These continue to go out this way, and the south side comes in. Finally, the cow magnet, which I'm replacing with the spherical magnets. Here I've got my iron filings. I'm going to hold that spherical magnet up. Wow, very strong. This one produces some pretty sharp patterns. And on the compass, so this here is the south pole, and then this here is the north pole on that side. So I get we had a south pole here and a north pole here, and these are wrapping around similar to what the other ones were doing, south to north. And this one really just looks like a kind of a mass of iron filings shooting out in all directions. All right, so that's in general how to draw a magnetic field around a magnet.